My name is K. Pranava and my roll number is 234G1A0488, and my topic on control systems is about the numerical on polar plot. So let's see what is mean by polar plot. So before we get into what is mean by polar plot, let's see the outline. What is the outline of this presentation? What is polar plot? Numerical on polar plot, solution, magnitude and phase plot table, polar plot graph, conclusion. So what is meant by polar plot? Polar plot, also known as Nyquist plot, is a graphical representation of the frequency response of a system. Plotting the magnitude of the transfer function against its phase angle in polar coordinates where the frequencies varies from 0 to infinity. That is by explaining in a simple method. So if you consider the before plots like board plot, root criterions and road clockers where we consider this magnitude and phase plots. Here we can for the it was created for the, so here we consider the frequency response of a system where we find the where we plot between the transfer magnitude versus the phase angle in the polar coordinates, which where the frequency varies from 0 to infinity. So this polar plot can also be called as an Nyquist plot. So numerical on polar plot. So let us take an example, that is the open loop transfer function of a unity feedback system is given by g of s is equals to 1 by s of s plus 1 into 2s plus 1. Sketch the polar plot and also determine the gain margin and the phase margin. So given for we know that they given the transfer function, that is g of s is equals to 1 by s of s plus 1 of 2s plus 1. So the above function clearly depicts that the system is type 1 and type 3, type 1 and order 3. So where we can return it as a 1 by s of 1 plus st1 into 1 plus st2. So now we'll consider s is equals to j omega. So we'll substitute the j omega in the places of s. So the above function in the form of the magnitude and angle can be represented as g of j omega is equals to 1 by omega 90 degrees. That is that we can write this transfer function in the form of magnitude and the angle as shown in the slide. So if we consider the angle part in the numerator, we need to insert a negative sign due to transition. That is as we consider from the denominator to numerator, now we are going to consider the transition sign, that is before the angle we are going to give the negative sign. So let us see how we separate the magnitude and angle terms from the above equation. So as we have seen here that we'll find the magnitude values, that is by considering the modulus given. Here we take that modulus of g of j omega is equals to 1 by omega of 1 plus omega square into 1 plus 4 omega square, like whole root square. So and again here the next is 1 by omega of 1 plus 4 omega square plus omega square plus 4 omega power 4 whole power 1 by 2, and the last 1 by omega of 1 plus 5 omega square plus 4 omega power 4 power 1 by 2. So angle of j omega is minus 90 minus tan inverse omega minus tan inverse 2 omega. So by substituting the, where we know that we are taking the values of omega as 0 and infinity, then we'll get the values of angles between infinity, that is minus 90, and at 0 minus 270. So by taking these values, we're going to plot in the polar coordinates. No, before that we have to find what are the magnitude and phase of the given plots. So by taking the radian per second, that is omega values of 0 0.35, 0 0.5, 0 0.6, 0 0.7 and 1.0, we'll get this uh, we'll get this magnitude and angle values. Before slide we have seen the magnitude values, right? So in that we'll place this omega value and find out the what is the magnitude of the of the given transfer function and also the angles that is given in this slide. This is 2.2, 1.2, 0.9, 0.7, 0.3, and here minus 144, minus 162, minus 171, minus 180, and minus 196 for the given omega values. So this is the polar plot. As we have known that for the infinity we have got the 90 degrees, right? So we take this coordinate and see how the value is going. So if here we'll consider the gain margin and the phase margin, which we'll see in the next slide, and how we calculate it. So based on the omega values given, we'll plot this in this unity circle. So before unity circle ends, if the crosses before the unity circle ends, then it is positive, that then the transfer function is given has the stability. So in the, so as we are seeing here, so here we'll consider the phase values, and the same here we consider the omega values, and here we'll draw this plot. So see, let's calculate the gain margin and the phase margin. We can see in the polar plot that the magnitude circle cuts the 180 degrees axis at the point 0.7. Hence, it will be the value of gain. GB. So we all know that the gain margin is given as 1 by GB. So as we have known that it cuts the circle at the 0.7 point, so this gain margin can be found as 1 by 0.7, which leads to the 1.428. So this is our gain margin for this polar plot value. And how we consider the phase margin is given by y is equals to 180 plus theta. That is, we can clearly see that the point marked with the red circle, it is the intersection point of the magnitude curve with the unity circle. The line drawn from the intersection point marked determines the theta angle, which is equals to minus 168 degrees. So by taking here the theta value is minus 180, so we'll get the value y is equals to 180 minus 168, which gives y is equals to 12 degrees, and by this we'll find that the phase angle value is 12 degrees. So for our given transfer function g of s, we'll get after taking the polar plot, finding magnitude phase plots, will have a polar plot graph. So from that we'll have gain margin and phase angles, that is gain margin is equals to 1.428 and phase angle is 12 degrees. So by the conclusion that from this presentation we have understood how the polar plot is drawn from the given transfer function by calculating its magnitude and phase angles. So when compared to the board plot and all, it is very accurate and have the good it explains the stability very well. Not only that, you can draw this graph in the polar, that is in the unity circles. We can also draw it in the normal graph by taking the magnitudes of the real and imaginary numbers. So this is how we draw the polar plot. Hope you understood this. Thank you.